Well, 5.3 says show that cos of 2 alpha can be written as 1 minus p squared over 1 plus p squared. Okay, it means that it can be written like that. We need just to prove it. Okay, cos of 2 alpha. All right, I'm gonna move my boat here. Let me. Okay. 5.3.3 says cos of 2 alpha is equal to 1 minus p squared over 1 plus p squared. Okay, that's 1 plus p squared. Okay. What do we know about cos 2 alpha? This is what you call a double angle. Cos 2 alpha can be given like as cos squared of alpha minus sine squared of alpha, or it can be 2 cos squared alpha minus 1, or it can be 1 minus sine 1 minus 2 sine squared of alpha. All these are formulas we can use to find cos of 2 alpha, double angle for cos. Now, I want to go through, let's do the first one. Okay. In the previous question, we did work out cos of alpha, and then we found that cos of alpha was this part. Okay, cos of alpha is 1 over square root of 1 plus p squared. Okay, so since cos alpha, okay, let me just paste this question here so we can all see how we get it. So this is what we had. And then we have said that, okay, it's going to be something like this. So we have like this triangle here. Okay. This one is x, but we found the value of x was 1. And then this is p. And then this also is found by applying the Pythagorean theorem. This makes 1 plus p squared. Now, cos of the angle being equal to, cos of the angle alpha will be being equal to adjacent over hypotenuse. Adjacent over hypotenuse, okay? This implies that cos of alpha here will be adjacent, which is 1 over hypotenuse, which is square root of 1 minus p squared. So cos alpha is equal to 1 over square root of 1 minus p squared. So which means that cos squared alpha, okay, let's first find sin alpha also. Sin alpha will then be sin alpha, which is given by opposite over hypotenuse. Then sin alpha will be equal to opposite, which is p, and hypotenuse is square root of 1 plus p squared. So it's going to be p over square root of 1 plus p squared. Now, if cos alpha is that, is given by this 1 over square root of 1 minus p squared, cos squared alpha then will be this squared, okay, which means cos squared alpha will be 1 to the power of 2, okay, over square root of 1 minus p squared, also to the power of 2, because that's the law of the exponent. The exponent says if you have a over b to the power of 2, this is a squared over b squared. So apply the law of exponent to solve this, okay? Now, sine, therefore sine squared of alpha would then be p over square root of 1 minus p squared. Excuse me, 1 plus p squared, plus, not minus. It's plus, yeah, I wrote accidentally minus instead of plus. Okay, to the power of 2 also. Then sine alpha will be then p squared, okay, for the same reason, 1 plus p to the power of 2. Okay, the power of 2 p squared, and then that is the power of 2. But now what happened? What will happen here? The power of 2 will cancel this root. Okay, the power of 2 here also will cancel the roots. Now we will then have we then have like sine. So that makes cos squared alpha will be 1 over 1 plus p squared, okay, and sine squared alpha will be p squared over 1 plus p squared. Now we have said, if now that we have worked it out, we do know now what cos squared alpha is. We do know what sine squared alpha is also. Okay, we can then substitute using let's say we're working out the first property. Okay, let's say let's split here. Let's say we're using the property that says cos of 2 alpha equal to cos squared alpha minus sine squared alpha. If we're using this, we will have cos 2 alpha will be, then we sub in the value of cos squared alpha, which is 1 over 1 plus p squared. So this will be 1 over 1 plus p squared minus, okay, the sine squared alpha, we did work it out earlier. Sine squared alpha is given by p squared over 1 plus p squared. So this will then be p over 1 plus p squared. Now note that at the moment that the denominator are common, okay, what we do, we can write it with a common denominator. So this implies that cos 2 alpha will be 1 minus p over 1 plus p squared, okay, p squared, p plus p squared. So we prove it. Yeah, proven. Or we can also decide if we want to use the other formula, cos of 2 alpha equal to 2 cos squared alpha minus 1. We can also use that one. We do know the value of cos, so cos of 2 alpha would be, then we do know the value of cos squared alpha. So we have like 2 cos squared is like 1 plus p squared whole under 1. Okay. Now minus 1, and then this will means cos squared alpha, no, cos 2 alpha, cos 2 alpha will be equal to 2 over 1 plus p squared minus 1. Minus 1 can be written as 1 plus p squared over 1 plus p squared, because all this is just 1. This is just 1. You can write 1 this way. And now that will imply that because the denominator are the same, we can just add the numerator. Okay, you have like 2 minus 1 here. This 2 minus 1 will be 1. So there will be 1 plus p squared over 1 that will be not okay. Over here, it's not 1 plus p squared, but rather 1 minus p squared. Careful when we have the negative sign outside the fraction. The negative sign here changes the sum of everything at the numerator. So this becomes -1. That's why we do 2 minus 1 is 1. And the minus here with the plus here makes minus also that makes negative p squared. So this is proven also. Similarly, we can also use the other formula of cos to alpha equal to 1 minus 2 sine alpha, sine squared alpha. It will end up the same thing. So this will be cos of 2 alpha will be, this will be cos of 2 alpha will be 1 minus sine squared alpha. The value of sine, we found it earlier. This was sine squared. So this will be 2 times p squared over 1 plus p squared. Okay. And this implies that cos of 2 alpha equal to 1 minus 2p squared over 1 plus p squared. Now, we can write 1 as, that makes cos of 2 alpha will be, 1 can be written as 1 plus p squared over 1 plus p squared, because all this is just 1. So, and then this one minus 2p squared over 1 plus p squared. Just the tablets, okay. 1 plus p squared. Now that the numerator are the same, we can just add the, now that the denominator are the same, we can just add the numerator, and then so that makes 1. We cannot, there's only 1 here, and there's no constant here, but we can do p squared minus 2p squared. It's negative p squared. So this will be, therefore, this will be cos of 2 alpha will be 1 minus p squared, because p squared minus 2p squared is just negative p squared over 1 plus p squared. So this is also proven. Thank you.